Let's now begin our examination of the case opposite of that of pure competition, pure monopoly. Monopoly means one seller. The term pure, in this context, refers to the fact that there is no government regulation. The monopolist faces no competition and no government regulation, and is therefore free to find the price-output combination that will maximize its profits. But how is it that a single firm emerges as the only producer or seller of a product in the industry? We must assume that there exists insurmountable barriers to entry, either financial, natural or legal. In our analysis, we will want to compare the cost relationships to the revenue relationships, to see what will be the implications of the firm's behavior, in its attempt to maximize its profits. We already know what the cost relationships look like, they're the same for all firms. Now, we need to figure out what the revenue relationships look like.
You may remember the basic principle that all revenue relationships are derived from the demand curve. If we can figure out what the demand curve looks like, we can derive the rest of the revenue relationships. All we need to do here is to figure out its slope. Recall that the demand curve for the purely competitive firm is perfectly elastic, a horizontal line, emerging from the vertical axis at the market price. But, why was it perfectly elastic? Because the industry was comprised of many sellers producing a homogeneous product, there was a virtually infinite availability of perfect substitutes. Is there an infinite availability of perfect substitutes for the monopolist's product? No. In fact, there are no close substitutes. If there were a close substitute, it would be considered to be in the same industry. And that industry then would not be a monopoly. So, because there are no close substitutes, the demand curve for the monopolist's product would definitely not be perfectly elastic. Well then, might it be perfectly inelastic? No, as we discussed in the module on elasticity. Might it be upward sloping? No. An upward sloping demand curve violates the law of demand. Then, by default, it must be downward sloping. The downward sloping demand curve indicates that the firm must lower its price in order to sell more units of output. If you'll recall, the purely competitive firm did not have to lower its price to sell more units of output. It was such an insignificant part of the total market that it could not affect market supply, and, therefore, the market price. But, when a firm is the only seller in the market, its output is the market supply. Because the monopolist produces the entire industry supply, if it wants to sell more units of output, it must reduce its price. So, now that we know that the monopolist's demand curve is downward sloping, we can derive the rest of the revenue relationships. They would be average revenue and marginal revenue. Let's start by creating a table listing quantity, price, total revenue, average revenue, and marginal revenue. We will assume that the monopolist's production capacity is 10 units per period. And, here are the market prices at which they could sell each quantity of output. If you look at this relationship upside down and backwards, you'll see that it's just a very simple demand relationship. Here's the relationship upside down and backwards. You may recognize it as the demand schedule we used to derive our very first demand curve. We express it this way in this table so we can base the other revenue variables, total revenue, average revenue, and marginal revenue off of quantity. Total revenue is computed, of course, as price times quantity. Average revenue is computed as total revenue divided by quantity. Notice that the values in the average revenue column are the same as the values in the price column. If we were to plot these average revenue values against quantity, we'd wind up with the very same curve, had we plotted price against quantity, the demand curve. As pointed out earlier, the average revenue curve and the demand curve are always the same. Marginal revenue is computed as the incremental change in total revenue.
Let's plot price against quantity, the demand curve. Now, let's plot average revenue against quantity, the average revenue curve. Notice that it lies right on top of the demand curve. Look carefully at the marginal revenue values, and compare them to those for average revenue. Notice that those values fall more quickly. And the marginal revenue curve will lie below and slant steeper than the demand curve. There's even a portion of the marginal revenue curve that falls into the negative quadrant. Now that we've derived the revenue relationships, let's see the revenue and cost relationships together on one graph. The monopolist, devoid of competition from other firms, as well as regulation from the government, is free to grope up and down this demand curve to find the price-quantity combination that will maximize its profits. The profit-maximizing quantity is no mystery by now. It occurs at the point where marginal revenue is equal to marginal cost. Here is the profit-maximizing quantity of output to produce. Notice the intersection of the marginal revenue and marginal cost curves. Now the firm must find the optimal price to charge. It is intuitively obvious that the profit-maximizing price would be the highest price possible, consistent with selling Q1 units of output, no more, no less. That price would be indicated by the demand curve. If we draw the dotted line up from Q1, the profit-maximizing quantity, to the demand curve, we get P sub 1, the profit-maximizing price. This is the highest price the monopolist could charge and still sell Q sub 1 units of output. So, now that we know how many units per period the monopolist is producing, and what he will charge for each unit, let's determine, given the information in this graph, if it is making a profit. If you'll remember our analysis of the purely competitive firm, economic profits can be determined by the difference between average revenue and average total cost. This distance, then, represents the economic profits being earned by this monopolist. Are these profits stable? Or will they be eroded away by other firms being drawn into the industry in search of those economic profits? Recall that there are insurmountable barriers to entry into this industry. These profits will not be eroded away. The monopolist will certainly not change things. Profits are being maximized. Therefore, at this point, the market is in equilibrium. There's one more issue we need to deal with before we complete our analysis of the pure monopoly market model: the efficiency implications of the monopolist's equilibrium. The first that we'll deal with is allocative efficiency. Recall that allocative efficiency occurs when price is equal to marginal cost at equilibrium. Price indicates the value that society places on this product, and marginal cost indicates the value that society places on the best alternative good that could have been produced with the same resources. If price is greater than marginal cost, society is saying, produce more of this product. More resources should enter the industry. If, on the other hand, marginal cost is greater than price, the society is saying, give us less of this product and more of the alternative product. If price and marginal cost are equal at equilibrium, just the right amount of this good has been produced, and resources have been allocated efficiently. This firm, and this industry, which are one and the same in the case of the pure monopolist, is in equilibrium. Profits are being maximized and there are no forces that will move the firm away from this position. Here is the equilibrium price at the profit-maximizing quantity. And here is marginal cost at equilibrium. For the pure monopoly, price exceeds marginal cost at equilibrium. Not enough of this product is being produced. Allocative efficiency is not being achieved. Productive efficiency means that the firm is extracting every ounce of productivity from its resources. There is no waste, no misutilization, and no squandering of resources. Average total cost is minimized at equilibrium. Is this monopolist minimizing the per unit cost of production? Although it is difficult to see on this graph, the firm is not producing at the lowest point on its ATC curve. Here is the point on the ATC curve at which it is operating at equilibrium. And here is the point at which ATC is minimized. It is the point at which the marginal cost curve intersects it. Although in this case, the difference isn't great, we can conclude that there is no force that will drive output to the lowest point on the average total cost curve. As a result, productive efficiency is not achieved in the case of pure monopoly. Finally, let's consider distributive efficiency. Recall that distributive efficiency occurs when economic profits are zero at equilibrium. Zero economic profits indicate that the entrepreneur's accounting profits are equal to what he would earn at his next best opportunity. That value is determined, we assume, by the competitive forces of the free market. We established earlier that the difference between average revenue and average total cost represents per unit economic profits. The existence of economic profits indicates that the entrepreneur is making more than the free competitive market assesses his value to be. In other words, the owner of the monopoly is being overpaid. Distributive efficiency is not being achieved.